All right, welcome back to Mr. G's lab. So we are going to be just doing a brief video on how to create ionic compounds. If you remember from yesterday, we would look at the periodic table and we would look at the ionic charge. So the ionic charge is, there we are, and we'd look at the opacity, the ionic charge, which is above group 1, group 2, group 13, group 17, group 16, and group 15. So if let's say that we were going to try to combine aluminum, or if you were in England, aluminium, aluminum, and you were going to combine it with, let's say, oxygen. We'd have to look up the ionic charge here for both of these. So let's aluminum, there we are, aluminum, and then oxygen. Okay. So then we go back to our periodic table and we look for aluminum, which would be in the boron group, which would be group 13, which would be here. So aluminum has an ionic charge of +3. So we go back to that. Has an ionic charge of +3. And then we also have to look for oxygen. And oxygen is in group 16 right here, the oxygen group. And our ionic charge is -2. -2. So if we go back here, we have it -2. Now, there's all sorts of ways that professors teach you. I'm going to teach you the easiest way, because the rest of the stuff, that's for organic chemistry, that's for advanced chemistry. For the basic stuffs, all you have to do is just basically, let me change my color, and we take our number, we ignore the positive sign, and we take our number over in oxygen and we ignore ignore the negative sign. So we take these superscripts, the numbers that are above, and we crisscross them. And we put them down as subscripts. So for every for every 2 pieces of aluminum, we got the 2 from here. And for every 3 pieces of oxygen, these 2 will combine to make aluminum oxide or aluminium oxide. And that's it. It's Al2O3. That's it. Now, if we were going to be working at a different one, we could use a different. All right, so we're going to do a different one, barium plus bromide. And barium, if we look at our periodic table, has barium's down here. It is in group 2, so we're going to be looking at a +2. And then bromine is way over here on the periodic table. It's in group 17. And bromine has a -1. So metals are going to have a positive charge, non-metals are going to have a negative charge. And if we crisscross, we take the superscript number for barium without the positive, the superscript number for a bromine without the negative, and we crisscross them. Move that one over here, and we move this one over here. So now we have BA1 and BR2. Well, we don't have to write the 1. We already know that is going to be the same. So it's going to be BA, BR2. If a chemist looks at that, they know that there's a 1 here, so that we don't have to write that. The same would be true, let's say that we have something like sodium, Na, plus chlorine, sodium chloride. Sodium has a positive charge, positive 1. Sometimes you just might see it as a positive. And then a negative 1. And we crisscross these. And then we have our I'm sorry. Then we have our and I apologize about that, but my PDF reader crashed. So if you're wondering why the color suddenly changed, that'll be why. So basically take the numbers and you move them as subscripts. You crisscross. And then you end up with Na1Cl1, and it can be I'm sorry, we don't write the ones, so then it would be just NaCl, and that can be for any any single same number subscripts. So, for example, if we were to take boron, boron has a +3, and nitrogen has a -3. We crisscross for their ionic charges. We crisscross, and then we're left with B3, which is here, B3, N3. They're both the same, so we don't have to write those. So then it would just be Bn. Every chemist is going to look and go, it has a perfect ratio, 1 to 1, or 2 to 1, 2 to 2, or 3 to 3, or in some cases 4 to 4. So that is it, and thanks a lot, and you all have a fantastic day. It is great to be with y'all, and peace.